the dark matter detective. In the vast expanse of our universe, a cosmic mystery has long puzzled scientists and stargazers alike. As we peer into the depths of space, we've come to a startling realization. More than 80% of all matter in the universe is invisible to our eyes and instruments. We call this enigmatic substance dark matter. This invisible cosmic scaffolding has fascinated and frustrated astronomers for decades. We can't see or touch it, but we know it's there, shaping the very structure of our universe. We see its effects in the way galaxies rotate, in the bending of light across vast cosmic distances, and the very formation of the largest structures in our universe. Some theories suggest dark matter consists of weakly interacting massive particles. Others propose subatomic particles called ions. But despite our best efforts, these particle-based searches have come up empty until now. Enter a groundbreaking new theory that takes us back to the very dawn of time: primordial black holes. These ancient relics are theorized to have formed in the first fractions of a second after the Big Bang, when the universe was an incredibly dense soup of energy and matter. Unlike the massive black holes that form from collapsing stars, primordial black holes could be astonishingly small, some potentially as tiny as a single atom, yet they could pack the mass of the largest asteroids into this microscopic space. This combination of tiny size and enormous density makes primordial black holes a perfect candidate for dark matter. But how can we possibly detect something so small and elusive? Scientists now believe that primordial black holes, if they exist, could be passing through our solar system about once every decade, and Mars, our rusty red neighbor, might be our best chance at spotting them. When one of these cosmic wanderers passes within a few 100 million miles of Mars, something extraordinary happens. The red planet's orbit wobbles ever so slightly by just 1 meter. It's an incredibly small change, equivalent to the width of a single grape in the vastness of Mars' 140 million mile orbit around the Sun. Asteroids and other space rocks follow predictable paths governed by the Sun's gravity. Primordial black holes, on the other hand, would be merely passing through their trajectories, unbound by our solar system's gravitational pull. To tackle this challenge, researchers are developing sophisticated simulations that model not just the planets and moons, but thousands of smaller objects as well. Understanding dark matter's true nature could help explain how galaxies form and evolve, how the largest structures in the universe came to be, and perhaps even shed light on the ultimate fate of our cosmos. As we push the boundaries of technology and theory, the search for dark matter continues on multiple fronts. As we gaze at the night sky, we're reminded that the greatest mysteries often hide in plain sight. The quest to understand dark matter unites astronomers, physicists, and dreamers around the world. The universe is full of surprises, and every answer we find leads to new questions. As we continue to explore and wonder, stay curious, keep asking questions, and never stop watching the skies.